Dear students, welcome to the channel. This is solving grade 12 mathematics Ethiopian University entrance examination in English presented to you by Umar Adam Umar. This is part 15. Now, as you remember, in our last video we have solved some of the question. Now today let us start with this particular example. This is question number 31. It says, assume that f and g are differentiable functions such that f prime of x is equal to minus g of x and g prime of x is equal to minus f of x. If h of x is equal to f of x squared minus g of x squared, then h prime of x is equal to dash. That is what the question says. Now, what we have to do is, we begin with this by derivating both sides of this expression here, as you can see. But first, let us collect what are given in the question. The givens are f prime of x is equal to minus g of x, it is given. And also g prime of x is equal to minus f of x, it is also given. What is required? It is h prime of x. And therefore, now from this equation, just differentiate both sides of the equation, which means when we derive h prime of x, then we have to derive f of x squared minus g of x squared. The derivative of f of x squared means it is equal to, first derive this power, which is 2 times f of x itself, and then by chain rule, then f of x must be differentiated, which means here 2 times f of x multiplied by f prime of x. This is chain rule. Minus, also again, here derive the power, which is 2 times g of x, and then by chain rule, derive g of x itself. It becomes g prime of x. Since our f of x is given here, f of x can be written as f of x is equal to minus g prime of x, and therefore replace f of x by minus g prime of x. Here, remember we have 2 here as a coefficient. And also, f prime of x is equal to minus g of x, then replace f prime of x by minus g of x. And here we have again minus 2g of x times g prime of x. Here, minus times minus becomes positive, and therefore the product of these functions becomes 2 times g of x, g prime of x. Here we have minus 2g of x times g prime of x. Then the result becomes 0. Therefore, h prime of x is equal to 0 is going to be the answer. Therefore, our answer should be here the one in multiple choice, B. That is solution for question number 31. Now let us turn to the next question. This question also says, question number 32. Given that the integral from 4 up to 9, the square root of x dx is equal to 38 over 3, what is the value of the integral from 9 up to 4, the square root of x dx? As you can observe here, inside the integration we have radical x, and also here inside the integration we have radical x. They are the same, but the difference is we interchange the upper limit and the lower limit of the integration in here. 9 and 4 are interchanged. 9 here becomes the lower limit of integration, whereas 4 is the upper limit of integration. Now, by the rule of integration, we have the integral of a up to b, f of x dx is always equal to the minus of. If we interchange, this is one of the property of the definite integral. If we interchange the limits of integration, we can rewrite this function as the integration from b up to a. If we interchange the limit of integration here, then simply write f of x dx. These are the two are always equal. Therefore, what we have to do is here, this one, the integral from 9 up to 4 radical x must be equal to minus the negative of this integration. Negative of this integration. Now here I have already done it as such. This is given, and what is required? The integral from 9 up to 4 radical x dx is going to be required, and therefore by the property of integration, definite integral, the integral from a up to b f of x dx is always equal to minus of the integral from b up to a f of x dx, and therefore the integral from 9 up to 4 radical x dx will be minus 38 over 3. That is the solution. It looks simple, but it is tricky. Therefore, you need to know the property of integration. Therefore, the answer is minus 38 over 3 is the answer, and therefore D is the right choice. Now let us turn to the next question. Question number 33. It says, let f be a function such that f of 1 is equal to 12 and f prime is continuous. If the integral from 1 up to 4 f prime of x dx is equal to 17, then what is the value of f of 4? That is the question. Now remember, by the rule of integration or property of integral, we know that the integral, the indefinite integral of f prime of x in integration, f prime of x dx is always equal to, now the antiderivative of f prime of x is f of x itself. Therefore, this is going to be the antiderivative, f of x plus a certain constant c. That is the antiderivative of f prime of x. And therefore, what we have to do is, here, the integral, not this one. The integral from a up to b f prime of x dx is always equal to f of b minus f of a. That is the rule. Now what are given? The givens are f of 1 is equal to 12 is given, and also the integral from 1 up to 4 f prime of x dx is equal to 17 is given. What is required? F of 4 is required. Now using this property of definite integral, what we have to do is, we begin from this one. The integral from 1 up to 4 f prime of x dx is equal to, by this property, it becomes f of 4 minus f of 1 is equal to 17. It is given. And then solve for f of 4. F of 4 becomes f of 4 is equal to 17. Then move minus f of 1. Since f of 1 is given, move to the right. It becomes 17 plus f of 1. But f of 1 is equal to 12, and therefore replace f of 1 by 12. Here f of 4 therefore is equal to 17 plus 12, which is equal to 29. That is the answer. The answer is, therefore, B is the correct answer. Now it looks simple, but it might be difficult if we don't remember the rules or properties of definite integrals. Now let us go to the next question. Question number 34. It says, what are the values of A, B, and C respectively, for which the graph of f of x is equal to x squared plus ax plus b, and the graph of g of x is equal to x cubed minus c intersect at the point 1, 2. At the point 1, 2. And have the same tangent line at this point. Now here, according to this question, this function, the graph of f of x and the graph of g of x, intersect us at this point. And also, both graphs do have common tangent line, the same tangent line at this point. This point is 1. It is the intersection point of the graph of f of x and the g of x, and also it can be considered as the point of tangency, since this line, the tangent line, the common tangent line for both function, touch both function at this point as a point of intersection. Now, we begin with this one. What are given? F of x is equal to x squared plus ax plus b, and the g of x is equal to x cubed minus c, and the intersection point is 1 and 2. Here, since this point is the intersection point of both f of x and the g of x, then it must, this point must lies on f of x as well as g of x. That means f of 1 is equal to 2 and the g of 1 also must be equal to 2, because this point satisfies both f and the g. Now, from the first function, from f of x, what we have is just replace x by 1, and then since our f of 1 is equal to 2, 1 plus a plus b must be equal to 2. And also from g1 is equal to 2, we have in place of x, just replace x by 1, 1 minus c, it must be equal to c. It must be equal to 2. Here, and then move c to the right and collect the number on one side and the variable on the other side. It becomes 1 minus 2 is equal to c. Therefore, the value of c is obtained. It is equal to minus 1. Now, here, observe these multiple choices. Minus 1. And we are asked a, b, and c respectively. The third one must be minus 1. If only one choice, one multiple choice, contains minus 1 at the end, then that is going to be the answer before we go any further. Therefore, here 1, 0, minus 1 found here only in choice B. Therefore, this is the only alternative that must be equal to the answer. Now, first, let us proceed. I'm sorry for some certain disturbance. We have in a common big stuff, and therefore there are noises. Now let us proceed, please. Here we obtain c, the value of c is equal to minus 1, and then from again 1 plus a plus b is equal to 2, by moving the number on one side, we obtain a plus b is equal to 1. A plus b is equal to 1. Now we need to find the value of a and the b, since we already get the value of c. Moreover, now here we have been told that both f of x and the g of x do have the same tangent line at this point of tangency, and therefore the derivative of the function or the slope of the tangent line for both f and the g are the same, and therefore here f prime of x must be equal to g prime of x. Since f and the g have common tangent line at 1 and 2 at this point, we have f prime of 1 is equal to g prime of 1, and therefore first derivate f of x. The derivative of f of x is 2x plus a. Therefore write 2x plus a, and the derivative of g of x is equal to 3x squared. Then here 2x plus a is equal to 3x squared. Then replace x, since f prime of 1 is equal to g prime of 1. Then 2 plus a must be equal to 3. 3 times 1 square means it is 3. Therefore solve this one. It becomes a is equal to, move 2 to the right, it becomes minus 2. Then a is equal to 3 minus 2, which is equal to 1. Now we have the value of a, which is exactly equal to 1. We have also the value of c, which is equal to minus 1. Here, since a plus b is equal to 1, from this equation substitute For 1 for A, then it becomes 1 plus B is equal to 1, and B is nothing but it is simply 0. We have now A is equal to 1, B is equal to 0, and C is equal to minus 1 respectively. Therefore, now the right answer is 1, 0, and minus 1, which is B. Now let us turn to the next question. Question number 35. It says, if the integral from 1 up to B, x to the power of n minus 1 dx is equal to 2 over n, then what is the value of B? That is the question. What is the value of B? Now B is going to be required. What are given? The integral from 1 up to B, x to the power of n minus 1 dx is equal to 2 over n is given. What is required? B is going to be required. And therefore, by the rule of integration, again, the integral from 1 up to B, x to the power of n minus 1 dx means it is x to the power of n minus 1, add 1 to this one, n minus 1 plus 1, over, write the same expression here in the denominator, n minus 1 plus 1, and evaluate it from 1 up to B. Since our lower limit is 1 and the upper limit of the integration is again B, then we need to evaluate this integration from 1 up to B. The x to the power of n minus 1 plus 1 means it is x to the power of n, and then n minus 1 plus 1 also is equal to n. Evaluated from 1 up to B must be equal to 2 over n. It is given. And then now this integration, again this value becomes b to the power of n. First replace x by b, and then subtract 1 over n from this one. Substitute 1 for x here, and therefore it becomes b to the power of n over n minus 1 over n is equal to 2 over n. Here move minus 1 over n to the right, it becomes b to the power of n over n is equal to 2 over n plus, since it is minus here to the left, but when it is moved to the right it becomes plus 1 over n. And take the least common multiple of the two, it is n, and add the numerators. 2 plus 1, it becomes 3 over n, b to the power of n over n, then cancel n by n. This implies b to the power of n is equal to 3. Then again here, we know that b to the power of n, if this thing is equal to, this exponent is equal to 3, then to find the value of b, what we have to do is take the power of 1 over n on both sides. On both sides of the equation. Here, take here 1 over n on both sides. Then n times 1 over n means n cancel n. What is left? Here we have only b. b is equal to, in this case, 3 to the power of 1 over n is the right answer. The answer can be written as such, or simply this means 3 to the power of 1 over n can also be rewritten as the nth root of 3. We can write like this one, the nth root of 3. Both are the answer. Now let us see what is there for us to answer. Here choice A 2 to the power of n, choice B 3 to the power of n, we don't need both, and choice C 2 to the power of 1 over n, we also don't need, and our answer is 3 to the power of 1 over n. Now if and only if b is 3 to the power of 1 over n, that this integration is equal to 2 over n. Therefore the value of b in this case is 3 to the power of 1 over n, or the nth root of 3. Now let us turn to the next question and the final one for this part of the video. Question number 36. It says, a table of values for f, g, f prime, g prime is given as shown below. This is a table. Now here the x, when our x is equal to 1, 2, and 3, f of x becomes 0, 2, and 6, and g of x becomes 1, 6, and 15, f prime of x 1, 3, and 5, and g prime of x 3, 7, and 11. Now the question is, if h of x is equal to f of g of x, then what is h prime of 1? That is the question. Now therefore, here we begin from this expression. We begin from this expression and derivate both sides or differentiate both sides. You can alternatively use that word. Derivative or differentiation are the same thing. Here g of x, this is composition of a function. Then if we derivate both sides of this function, then we need to apply the chain rule for this one. Here h prime of x becomes f prime of g of x and also multiplied by g prime of x. That is called the chain rule. It is called the chain rule, and therefore the derivative of h of x becomes here f of g of x becomes f prime of g of x and multiplied by g prime of x. And then now find the value of h prime at x is equal to 1. What is the value here? At h is equal to 1, at x is equal to 1, h prime of 1 becomes f prime of, here, since I have already solved it here, h prime of 1 is equal to f prime of g of 1 multiplied by g prime of 1. And what are these values then? What is f prime of 1? As you can see, f prime of 1, when our x is equal to 1, it is equal to 1, and therefore it is given f prime of 1 is equal to 1, and g of 1 is equal to 1 from the table, and g prime of 1, as you can see, it is 3. When our x is equal to 1, g prime of 1 is 3. When our x is equal to 2, g prime of 2 is equal to 7, and so on. Similarly, when our x is equal to 1, f prime of 1 is 1. When our x is equal to 2, then f prime of 2 is 3, and so on. And the same for this one also. And then here we say g of 1. What is g of 1? G of 1 is 1. And then f prime of 1 in this case is also, f prime of 1 is also 1. But g prime of 1, as you can see, it is 3. Therefore, 1 times 3 gives us 3 itself. Here, see here. H prime of 1 is equal to f prime of g of 1 multiplied by g prime of 1, which is equal to f prime of, since g of 1 is equal to 1, we have f prime of 1 multiplied by g prime of 1 is 3 multiplied by 3. And therefore, here f prime of 1 is also given from the table. It is equal to 1. 1 times 3, it is 3. Therefore, the correct answer in this case is the one in choice A is the right answer. That is it for today. Please try to copy this question together with the given solution and then practice it. After the practice, you will understand many as similar question. Therefore, now for until we meet next time, please, if you love this video, try to subscribe and like and share. Have a good time. See you next time in our next video, just soon after a couple of days. Thank you.